Hi everyone, welcome to .NET 6 Microservice series. So this is the fourth video. In this video, we are going to deal with asynchronous data communication between microservices using RabbitMQ message broker with MassTransit. Okay, so the main theme is how to asynchronously we can communicate our both microservice application. Okay, with the help of message broker like RabbitMQ. Okay, so if you recall our previous video, we have created a microservice application like Sales Business API. In that, we have an endpoint like orders, right? And we also observed that in the orders, we only have product ID, but there is no uh, relevant information regarding the product in the orders. Okay, how we can achieve the product information while we invoking the orders API as well. Okay, so today we are going to accomplish that goal in this video. Okay, so here is our flow of our microservice architecture project. Okay, we have created microservice one that contains product API, and we have created another microservice application that contains order API. Now here you can see message broker that is going to create a asynchronous communication between these two microservices. So here my goal is whenever a product is created, okay, a product is inserted into the manufacturer database, means we are going to invoke the products post endpoint, right? So whenever we are going to save, at that time we want to send that product information as a message to the message RabbitMQ message broker. Okay, so that what will happen, it that data or that message can be read by our another microservice application, that is sales business API application. Okay, and then once that message is received from the message broker, what we will do, we will create a one more product table in the sales business database. So this product table is a child table. Okay, so manufacturer database contains parent product table that contains all the columns like product name, product description, product actual cost, product offers, everything will be inside of that table. But here we are going to create a tailed product table. It will contain exact data of this manufacturer database, but it will contain only required properties. Like for this demo, I will create only table columns with product ID and product name. Product ID is the primary key that should be matched with the parent product table, and product name that will display the what is the product user is ordered. Okay, so we are going to create a table. So using this consumer configuration inside of this microservice application, we are going to insert that data into the child product table. That means here an asynchronous communication is going on. Okay, why? Because whenever the product is saved in the manufacturer database, at the same time, same data will be saved into the sales business database, into the child product table. Okay, that communication is carried out by the RabbitMQ message broker. Okay, so what is RabbitMQ? RabbitMQ is a message broker. We know that it has several type of exchange flows. So let's understand them. So RabbitMQ supports different exchange types like direct, topic, headers, and fanout. Okay, by default, RabbitMQ uses fanout exchange. So same fanout exchange we are going to use in our demo as well. So we also use this fanout exchange for our demo. So in fanout exchange, whenever a producer sends a message, okay, whenever producer sends a message. So in our application, what is the producer? Producer is our products API endpoint. Okay, whenever producer sends a message, RabbitMQ, then the message will be sent to the fanout exchange. So something like a disk memory that is allocated to the RabbitMQ, there it will create like a fanout exchange. Okay, so message will be stored into the fanout exchange. So whenever the message is stored into the fanout, that message will be pumped or pushed over to all the queues, every queue that is connected to that our RabbitMQ message broker. Okay, it will send every queue that message. So once the queues are registered with the consumers, so whenever the message is arrived into the queue, consumer will reads the message. Okay, so in our project, our sales API, sales business.api project will be our consumer project. Okay, so here is the pictorial representation of the RabbitMQ fan out. So whenever producer sends a message, that message first goes into the fan out. So whenever the message is in the fan out, every queue in the RabbitMQ will receive that message from the fan out. Okay, fan out will send to every queue. So those queues will be consumed by respective consumers, so they can read the message. Okay, this is the RabbitMQ fan out exchange flow. Okay, so I have also mentioned along with the RabbitMQ, we are also going to use MassTransit, right? So what is MassTransit? So MassTransit is a free open source software that can wrap around message brokers like RabbitMQ and Azure Service Bus or SKS or Active MQ Service Bus. So it is a software, okay, to handle the message brokers very easily. It can be very helpful for the configuration. So MassTransit makes the configuration very easy with the message brokers. Okay. So now what we will do, we have to run RabbitMQ or set up RabbitMQ into our local machine, right? So I am going to use the Docker image running as a container in my system. Okay, so it is very easy to configure the Docker, right? So I am going for Docker based containerization for the RabbitMQ. So what we'll do, we are going to create a Docker compose file for RabbitMQ so that we can easily run the container for our RabbitMQ image. Okay, so here our projects are creating, right? So let me create a new folder like Docker setup. Okay, open VS Code. So in this folder, we are going to create the Docker compose file, right? So let's add our Docker compose file like docker-compose dot YAML file we have to create. Okay. So here we are going to add our setup. So first is version. So this version is for the Docker setup, Docker compose file. Okay. So latest version is it will support is 3.8. You cannot give a random. Docker compose by default support some versions. We have to give those versions only because based on that version, the syntax compatibility will work. Okay. So after creating version, we have to register our service, right? So we have to create a property like services. Okay. So inside of this service, we have to define name to our service. So I want to run RabbitMQ, right? So I will create a meaningful name like RabbitMQ. Okay. Under this, I want to define the original name of my RabbitMQ. Okay. Docker name. So the original name is RabbitMQ. Okay. Version 3 management. So if you want to check this, you can go to the Docker Hub where you can find the image name as it is and the versions, what are the latest version. Currently at the time of recording, it is 3 and the management. Okay. And next we have to define the ports. Okay. So ports. So first port is here I am going to define two different types of ports. So first port is whenever we run a RabbitMQ, RabbitMQ provides us a dashboard. So first we have to define the port for the dashboard. So by default, the dashboard port runs under 15672. Okay. So I have to export this port. So what I will do, I will export this port to same port number. If you want to give different port number, that is also fine. Okay. And it should be okay. So this is the port for the dashboard, RabbitMQ dashboard. So next port we have to define that is actual port of the RabbitMQ. So actual port of the RabbitMQ is 5672. Okay. If you want to expose same port number, you can expose, but I will expose for different port number, custom port number. I will export for 4001. Okay, so first port number is the dashboard port number, second port number is the actual RabbitMQ software runs port number. Okay, and finally, let's define the container name for my image to run. Okay, you can give any name. So I will give name like my RabbitMQ. Okay, so to run this in our local machine, this Docker composed file, we must install Docker desktop and it must be running before we run this Docker compose file. So let me run my Docker desktop application. You can download it from the Docker official website. So based on your operating system, it provides the desktop application. If it is a Mac, you will get the Mac version. If you is a Windows, you can download the Windows version of the Docker desktop application. Okay, let me open it. So here you can see my Docker desktop is up and running. You can observe like this Docker desktop application. Now let's run the our RabbitMQ Docker image container. Okay, so the command is like Docker -compose up -d means detached mode run this container. Okay, container is up and running. You can see container my RabbitMQ started. Okay, and now you can access the RabbitMQ dashboard with this port number. We are exposing with same port number, right? So here you can see, right? Docker, this is the Docker desktop, sorry, not Docker, RabbitMQ dashboard website. So default password is like guest, username and password also guest. Okay, you can see dashboard like this. Okay, here you can see exchanges. Okay, our messages we can see here. Okay, so that means RabbitMQ is successfully running in our local machine with the help of Docker image container. Okay. Next thing is we have to create a shared library. Okay. So in that library, we will create DTOs or models. So those DTOs are for messages, transferring the messages to the RabbitMQ. Means those are the types for our messages of the RabbitMQ. So we are going to create a shared folder and those classes, so that shared class library will be imported into the both our microservice application so that we can use those types for publishing or consuming the messages from the RabbitMQ. Okay, first let's create the class library. Okay, here is my command for creating a class library in .NET Core. So command is like .NET space new space class lib space -o space name of your class library. Okay, let's create the shared class library project. So in real application, you can uh, convert this library as a NuGet so that we can easily import into our application in real time scenarios. Okay, so now let's open the project. Okay, this is our class library project. Let's delete the existing class file. So let me delete this existing class file. So our main target of this library is to store the models of our RabbitMQ, right? So what I will do, let's create a folder like RabbitMQ models. And in this demo, we want to deal with the message transfer between the two microservice applications, that is creating the product, right? So I will create a model like product created. Okay, product created. So I have already mentioned, right? I just simply want to transfer or save product ID and product name into the new child table that we are going to create in sales business, right? So message contains only simple data, that is product ID, which is primary key of the original product table, and next product name. So let's define those properties here. Okay. So our product created looks like this. Now just build the project. Okay. Okay. Now our library is successfully built. What you have to do means we have to add the reference of this project into our both microservice application. So from Visual Studio, it is very easy. From .NET CLI comments, I will show how to add the references of the other class libraries. So here is my command for adding the shared library to our manufacturer API. So command is like .NET add and manufacturer API folder name and the CS project name is reference, and next shared project folder name and shared folder project. Okay, let's add the reference, and you can see that shared library is successfully added. Same way we have to add the our shared library into the salesbusiness.api. So let me create the command for that as well. Okay, so here is the command for adding the shared library into the sales business API. Sorry, let me correct me the command. Okay, now both the projects contains the shared library reference. Now first let's try to configure the publisher in the products endpoint. So to configure publisher configuration, let's go to our uh, manufacturer.api application. So here we want to configure the mm, publish, means that going to communicate with the RabbitMQ to publish some message. Okay, so in this post async action method, we are going to implement the logic. Okay, so to use the RabbitMQ along with the MassTransit, we need to install three NuGet packages, okay, that are relevant to the RabbitMQ and MassTransit. So first, let's install them. Okay, so these three NuGet packages need to be installed on both the microservice applications. Okay, both the applications. Okay, the first NuGet we have to install is MassTransit. Okay, so copy the command from .NET CLI. Visual Studio users can copy the command from package manager. Where so I am using .NET CLI, right? So I am going to copy from here command. So first I am going to install in the manufacture.api project. So run the command. So the second command I have to install is MassTransit.ASP.NET Core. Okay, copy the command, install it. The third package that I am going to install is MassTransit with RabbitMQ. Okay, copy the command, install it. Now let's configure the RabbitMQ and MassTransit services into the program.cs file in manufacture API. Okay, so go to program.cs file. So let's register services and add mass transit. Okay, let's import the namespace. Okay, here let's add some options. Okay, here I want to first configure the RabbitMQ as a message broker, right? So to configure RabbitMQ, we can use options.use use RabbitMQ. Okay, So to this RabbitMQ, we have to pass an async anonymous function. Okay, context and config. And here I need to specify the host because I am explicitly specified the port number, right? So I need to define the host here. Okay. So to define the host, config dot host, that we can pass new URI. Okay. To frame the RabbitMQ URL host, we have to specify like RabbitMQ colon slash slash localhost. And what is the port number? Actual RabbitMQ service is running. RabbitMQ service running under 4001. So same port number we have to define here. Okay. And next we have to pass the credentials for the host. Okay. Default credentials like username and password are guest. Okay. So let me define username and value is guest, right? And same way password value is guest. Okay. So that is the services we have to register for the RabbitMQ along with the MassTransit. So this is the use of MassTransit where we can configure RabbitMQ very easily and simply. Okay, now we configure the required RabbitMQ services. We have to publish our message. So to do that, go to product controller. Okay, and we have one interface like private read only. I publish endpoint. Okay, publish endpoint. So let's import it from the MassTransit. Okay. So what it will do, it will act as a publisher for messages to the defined service. What we defined inside of the MassTransit, we defined the RabbitMQ, right? So it will publish the message to the RabbitMQ. So we can inject the I publish endpoint. Okay. So now in the post method, once the record is post saved into the product table, okay, in the manufacturer database, we have to send the message. We can use iPublish endpoint. Okay. And here you can say publish. And here we have to define our model that we defined in our shared library, that is product created. Okay. The type of the message. Okay. Product created. Okay. So let's import the namespace. Okay. And inside of it, let initialize the product created object and pass the data. So ID will be the, so what it will contain ID, which is the primary key of the product table. So new product dot ID, once record is added, ID will be populated. So we can consume that. Next, name of the product we want to pass. Okay. So new product dot name. Okay. So whenever we create a new product, once that is saved into the database, its information will be pushed into the RabbitMQ fanout exchange using the publish endpoint. Okay. So that's the changes we have to add in manufacture API microservice application. Okay. Next thing is, okay. Now the thing is we need to create a product table that is a child product table. We have to create in the sales business database. Okay. So here is the script. So this contains only two columns like ID and the name. Okay. After creating, you can observe in sales database, we have a child product tables along with the orders table. So the product table contains ID and name, whereas the original product table that is in the manufacturer database that contains more number of product information. Okay, so like this, our DB structure looks like this once we create the sale products table. Okay, now in the sales business API, we have to create a model for this products table, and also we have to add it to the database context. Okay, so go to the sales business project. Okay, here we need to create one more entity in the entities, that is like product.cs. So this is our products entity. Let's add the columns as a properties that are like ID and the name. Okay, so our products entity look like this. Now let's register this entity in the DB context as well. Okay, so here let's register our products entity as well. Okay, and now we have to install all the NuGet packages what we have installed previously into the manufacture.api project here as well. So our sales business is act as a consumer, okay, consumer project, okay, but we need same NuGet packages. So the first package I want to install MassTransit. Copy the command, install it. So the second command I have to install is MassTransit.asp.core. Copy the command, install it. And the last package that I want to install is MassTransit.RabbitMQ. Copy the command, install it. Okay. Now we have to register the RabbitMQ and MassTransit services into the program.cs file. But before registering them, we have to create a consumer entity inside of our sales business project. So in manufacture API, what we did, we just injected publisher, right? So publisher it will not always connect with the RabbitMQ. Whenever message is available, at the time if it is connected, that is fine. Whereas consumers should not be like that, right? They always interact with the RabbitMQ queues so that they can, if any new message come, they can read them, right? So for that we have to uh, create a one consumer class inside of our sales business API. So for that, what I will do, let's create a folder like consumer. Inside of it, let's add a entity like, so we are dealing with product created message, right? I will name like product created consumer. Okay, so this is my consumer class that is always listens for the RabbitMQs to read the product created message. Okay, okay, this is my class. Currently, it is a normal plain class. To make it a consumer, we must inherit with a consumer interface. Okay, of type. So let's import the namespace MassTransit. Okay, that iConsumer comes from MassTransit, and what type of message we want to read. We know that we have created a shared class library like product created class, right? So we need to import it here. Okay. Now let's import the implementations. So this method gets invoked every time whenever a new message is arrived into the RabbitMQ queue from the fanout exchange. Okay. So here what I will do will be asynchronous call, and here I am going to inject the my database context. Okay. Okay, injected the sales business context. Now we have to receive the message from the RabbitMQ curate. So from this context we can read. So what I will do, let's create our product. Okay, so new products, my table class name. Okay, let's change the name, correct it, products. Okay, and in the context also, products. Okay, and now let's import the products namespace. Okay, now it is good. And what it will have id, so context dot message dot id, so message type is nothing but our product created type. Okay, and the name context dot message dot name. Okay, so we have received our message. Now what I want to do, I want to save it into the database. Okay, products dot add product and await save changes. Okay, so this is our consumer class. What we are doing, we are reading the message and saving into the database. Now go to the program.cs file and let's register our MassTransit and RabbitMQ and also our consumer service. Okay, so to do that, builder.services.add MassTransit. Okay, let's import the namespace. Okay, and define the options. So first thing, let's add consumer to the MassTransit. Okay, consumer of type product created consumer. Just we defined a class, right? That class we have to register here. Okay, so copy that name and register here. Next, let's register the RabbitMQ, use RabbitMQ, and inside of it, similarly like previously we have defined, right? Same way we have to define. Okay, so what I will do, I will copy it from the our manufacturer registration. Okay, okay, I have registered the host, but here we need to register additional configuration like consumer with the queue name. Okay, so config dot receive endpoint, and here I can define the queue name. Okay, name of the queue, anything. I will name it like event listener. Okay, so from this queue, let's read the messages. Okay, like that. And here we need to configure the consumers. Okay, configure consumer. Okay, and here also we have to define the product created consumer type here. Okay, and here we need to pass the context. So that's it. So it's almost similar to the registration we initially did for manufacturer API, but only change is we need to configure the register the our consumer entity, and also we need to register the queue name of the RabbitMQ and the consumer that is going to read that queue. Okay, that's all. We are done with the changes. So let's test our asynchronous data communication. So for that, what I will do, first thing, make sure our two projects running under different port numbers. Means my sales business API and manufacturer API runs under different port numbers or not. Okay. So to change the port numbers, if you want, you can go to the properties and go to the launch settings. Okay. So my port number is like 5139 for sales business API, and for manufacturer API, let's go and check, and 5137. So those two are different port numbers, so there is no problem for me. Okay, 7177 HTTPS, and for HTTPS 7135. Okay, so non HTTP 5139, and here 5137. So so those are running on a different port number. That is the first step we have to check before running, and make sure our Docker desktop is running, and also our this is my container for the RabbitMQ, right? That is also running. So here my both the applications are running. So now what I will do, I will run my manufacturer API first. Okay. Okay, this is my manufacturer API. It is up and running. Same way, let's run our sales business API project microservice as well. Okay, my sales business also running. And here you can see our manufacturer products table, which is a parent table. It is empty, and manufacturer, sorry, products table, that is a child table in the sales business database, that is also empty. Now, if our communication, asynchronous communication between our microservice is successful, whenever we create a product, it will be stored in main table that is inside of the manufacturer, and also child table that is inside of the sales business. So let's go to add one product. Okay, go to the product. So if we successful, then both tables get be populated with the information because of the asynchronous communication. Okay, let's try to add a new product like metric dumbbells. Okay, so some 1000 bucks and workout tool. Okay, so let me create this product. Okay, and here I got success product is created. Now if I go to my first table, main table, let's check whether it is added. See, this Patrick Dumble record is added. Now let's check our child table. If our asynchronous data communication with the RabbitMQ works, this table should get the data. If I run, see, with same record ID, I have product table. That means my asynchronous data communication with the help of RabbitMQ message broker is successful, right? It is successful. Now what I can do, so here is my orders in the orders table in the sales business, right? So what I will do, I will update the product ID for the, I have only one record, right? So I will update it. This is my old record when we don't have asynchronous communication at the time created record. Okay, let me update product ID for it. So product ID like 8002. Okay, sorry, 1002. Okay, let's update it. Okay, so now I have an order for this product. Now, whenever I invoked orders endpoint, now I have to get the product information as well. So our sales business have now product information as well, right? Now we need to fetch the product information as well along with the orders. So for that, let's go to our manufacturer API, sorry, sales business API. Okay, let's close all the open files. So first, let's create a DTO for our orders. Till now, we haven't created any DTOs, right? So create a folder like DTOs. Inside of it, let's create a DTO class like orders DTO that contains product object as well. Okay. Okay, here is my orders DTO. So let's create the properties. Okay, finally my DTO orders DTO class look like this. It will have product information as a product object. Okay, now go to our orders controller. We need to update the get endpoint. Okay, so what we can do, we can use join. Okay, we want to join with orders with product table, right? So let's do that. We want to join by the product ID, right? And it should be product ID. Okay, and order comma product order product. Okay, we need to select them. Dot select new orders DTO. Okay, so here we need to map the properties. Okay, so here is the changed query. So what we are doing, since now we have product information, we are joining them. Okay, now save everything and run the endpoint. Okay, now let's test our orders get endpoint again. And now okay, you can see previously we have only product ID, right? We have product information as well. So we have successfully implemented the asynchronous data communication between the two microservices. So in this video, we have finally accomplished our RabbitMQ message broker for asynchronous data communication between our two microservices. Okay. So next will be the last video of our series where I am going to create a API gateway to make a single domain for the client applications to consume different microservices endpoints. Okay. So that's all about the asynchronous data communication using RabbitMQ. I hope this video has delivered some useful information to you all. If you like my video, please support me by subscribing to my channel. Soon we are going to meet with new videos. Until then, signing off.